Hello everyone, it's Mr. Wolfe here, and in this video, I wanted to run through and explain the thinking process and the parts of graph for velocity versus time graphs for objects that are changing velocity, either increasing speed or decreasing speed. So what I want to do is I'm going to have my objects either speeding up, slowing down, but they can be speeding up in the positive direction, speeding up in the negative direction, slowing down in the negative direction, slowing down in the positive direction. So let's go over all of those. Let's start off with the easiest one where we're going to start at an initial position of 0. My velocity is going to be at 0 at rest, and then I'm going to have an acceleration of 2 meters per second per second. Now, that's a positive number, which means the acceleration is going to the right, and the acceleration we'll learn later is the result of a push, so my object should start to go to the right as well. So I'm going to click play, and we have our x versus t graphs, which we've seen before, right? And here I have this curved line, and as time increases, my slope's increasing, so that makes sense. My object's increasing speed, but let's look at the velocity versus time graph. All right, here would be my x-axis because this is 0. So as time increases, my velocity values increase. That makes sense. All right, now also look at is that since my object's going to the right, it's in the positive direction, positive slope here, that all my velocity values are also positive. Right? And so a way that I can say it is I know that this is going in the positive direction because it is in the positive quadrant. All those y values are positive, and I know that it's increasing speed because it's getting further away from the x-axis. My velocity values are getting greater. All right, so now what I want to do is I want to have it speed up, but this time in the opposite direction. So I'm going to reset, and then I'm going to make everything where I'm just going to make my acceleration negative 2 meters per second. So the same acceleration, but now the direction's going left, so my object should go to the left as well. And if we look at our position versus time graph, that's exactly what's happening. I have a negative slope. My slope's increasing, so my object is increasing velocity too. The only difference is it's now just to the left. So now let's look at our velocity versus time graph. All right, and we can see that the line goes down. And immediately, sometimes our brain's like, oh, look at lines going down. It must be decreasing speed. All right, but let's really start to analyze it here. As time increases, all right, my velocity values, the magnitude, the actual number of the values actually get bigger, right? From 0 to 30 meters per second. The negative doesn't mean it's a smaller velocity, it just means it's going to the left. So anytime our line is getting further away from the x-axis, that means our velocity is increasing. It could be getting further away from the x-axis, going upwards like this or downwards like this. As long as I'm getting away from 0 meters per second, I am increasing speed. Now also notice that since the reason why it's going down is because it's going in the negative direction. Before, or at least now, all my values are in the negative quadrant, right? Which means all my velocity every time is going to be a negative velocity. It's going to the left. All right. So next thing I want to do is look at slowing down. So I'm going to bring my acceleration back to 0 just for now. I'm going to set my velocity to 10 meters per second. So my object's initially going to the right, and if I want it to slow down, we'll learn about this later, but your acceleration and velocity are going to actually should be going in opposite directions. So then I'm going to press reset, and I'm going to press play, and I'm going to pause it right there, all right, just for the purposes of this video. And it's a little bit tough to see, but our slope is decreasing, which means I'm decreasing speed, positive slope, so it's going in the positive direction. And my line's going down here. So if I read this graph, as time increases, velocity, the magnitude of my velocity is decreasing. That makes sense until it looks like it gets to rest right here. Okay. Now, how I know it's going in the positive direction is the whole time my velocity values are positive, right? In other words, all my data points are in the positive quadrant. That's how I know it's going in the positive direction. So now let's just reverse direction. So now my object's initially speeding up at negative 10 meters per second. And to slow it down, I'm going to have acceleration going in the opposite direction. So let's reset, press play. And just for the purposes of this video, I'm going to pause it here. And if we look at our x versus t, as time increases, my slope starts to decrease. So my velocity is decreasing, slope's negative, so I'm going in the negative direction. So everything checks out there. Now let's look at our velocity versus time graph. Remember, our x-axis is here. So even though our line is going up, we're slowing down. So why is that? Again, we got to pay attention to our y variables here. As time increases, my velocity values, don't worry about the negative, just worry about the actual numbers. My velocity values actually start to decrease to 0 meters per second. So anytime I'm getting closer to the x-axis, I am decreasing speed. All right. Now, in terms of the direction, like we've talked before, negative quadrant, all like the entire time that this is happening, all my velocity values are negative, which means I'm always going in the negative direction in this case. All right, so hopefully this video was helpful for not just seeing what these graphs look like compared when they're matched up with our x versus t graphs, but also how to better interpret our velocity versus time graphs, because they can sometimes be a little unintuitive, right? Sometimes you might look at this graph and you're like, oh, look at that line's going up, I'm increasing speed. But when we start to really interpret it in more detail, we see that in this case, it's actually increasing speed. Hopefully this helped. Thanks for watching.